Good afternoon, good morning, and good evening to everyone. We will give a couple of minutes for additional participants to join. We'll start shortly. Good afternoon, good morning, and good evening to everyone. Thank you for joining day 2 of our WHO EPI-WIN webinar series on ship inspection and issuance of ship sanitation certificates. I'm Sophia Song, and I'll be your moderator today. So just to provide a brief recap of day 1, yesterday's session, we heard from Dr. Ninglan Wang on the international legal framework of ship inspection and issuance of ship sanitation certificates. And we learned how to use the WHO IHR list of authorized ports to issue ship sanitation certificates from Ms. Sarah Barragan-Montes. Mr. Martin Walker presented an overview of pre-inspection planning, including equipment and arrangements. And Dr. Barbara Mustori explained to us the risk assessment and control measures for different vessel types. And Dr. Yaya Alamasi presented on the overview of issuance of a ship sanitation certificate and evidence report forms. We also heard from Dr. Thijs Winstra from the Netherlands and Dr. Leila Bouziani from Morocco on how their country's experiences on conducting ship inspections and issuing ship sanitation certificates were conducted, how they went. And moving on to today, we have another exciting and packed agenda, starting with Dr. Amor Seleman, who may not be able to join, in which case we have Dr. Remedios Kakulu, Principal Environmental Health Officer and National IHR Focal Point from MOH Tanzania, to give us the experience of Tanzania. Next, we will have Dr. Yaya Alamasi, Manager, General Director of Health for Borders and Coast of Turkey, who will present to us on food safety. The following presentation, we will have Dr. Rashdi Abdulrahim, Epidemiologist and Head of Health Control at Border, Tangier Tangerville Port, tell us about medical facilities and medical waste. Next, Dr. Martin Walker, Independent Points of Entry Specialist at London Port Health Authority, will present on potable water and water sampling. After which, we will have a discussion session moderated by Ms. Sarah Barragan-Montes, and a short break will follow. And after the break, Dr. Barbara Mustori, Professor of Hygiene and Epidemiology, Director of the Laboratory of Hygiene and Epidemiology at University of Thessaly in Greece, will present on sewage, followed by Dr. Rashdi giving us an overview of vector control on ships. Next, we will have an interactive photo-based exercise facilitated by Dr. Barbara. And our final presentation today will be on ballast water, given by Dr. Yaya. And discussion session will follow, facilitated by Sarah. And finally, closing remarks will be delivered by Dr. Ninglan Wang. Before we get started, we wanted to let you know that the webinar is being recorded, and afterwards, the recording along with presentations will be available on our website. The address will appear in the chat during the session. Please keep all comments respectful, positive, and constructive related to the topic. Certificates of attendance will only be sent to those who complete the end of webinar survey and that you will receive from Zoom. And lastly, please add any questions you may have to the Q&A box and not in the chat, so we can more easily keep track of them. So now, without further ado, I would like to invite to the floor Dr. Remedios Kakalu from Ministry of Health, Tanzania.
Okay, hi everyone, and good afternoon. In Tanzania is good afternoon. I know other countries might be good morning. So I'm here to present on overview of ship sanitation inspection and the issuance of ship sanitation certificate, a case of Tanzania. This presentation was meant to be presented by Dr. Moore, who have been engaged in other activities. So I will present on behalf. But also I recognize the presence of other Tanzania facilitators as part of panelists. So maybe in the question and answers, they also respond. So people from also Zanzibar who are also represented in this meeting. Yeah, so for those who do not know about Tanzania, this is the United Republic comprised of the Tanzania mainland and Zanzibar. It is located along Indian Ocean. You can see the map. And then it has a total population of around 62 million people. And according to that census, it has a total of 24 designated ports. And 18 we are located in Tanzania mainland, and 6 are located in Zanzibar. We have also, our ports serve as several countries, because I think majority of the countries surrounding Tanzania, they are locked. So they use mainly the Indian Ocean through Dar es Salaam port. So our ports serve not only Tanzania, but also other countries. To talk about, very brief about the port services in general, we run services not only at the ports, but also in other types of POE, including ground crossing and airports. And this, the main objective is to prevent and control cross-border movement of diseases, but also vectors, vermin, and other public health events. Specifically, we prevent entry and exit of diseases, and also provide early warning, alert notification, but also we have capacity to initiate a response at our points of entry. And in that sense, we have been working I think Tanzania has a long experience in terms of port health services, because we started having port health services way back in 1952. And we are covering more than 59 points of entry. And the government has dedicated a lot of resources to support the core capacities and international health regulations, as you remember, and Article 19 on general obligation on points of entry. And currently we have over 500 staff of different cadre and different education level, at diploma, bachelor level, and master's level, working at our points of entry. And these are permanently employed. They are not contract staff, but also have staff working on the marine. And all of our ports have been supplied with walk-through thermal scanners for health screening of travelers, but also the government has provided transport facilities. We have standby ambulance in case of any suspected case, and we also have motorcycles to facilitate movement within the port, because our ports is a big one. It requires regular movement, because our port services not only inspect ship, but they also do other activities, including goods and the products which are being imported into Tanzania. And we have installed isolation units and we work in collaboration. We have also port hospitals to support issues around case management, and we have provided inspection tools. When you look at the guidance for the handbook on ship inspection, there is an annex which specify the kind of tools which you are supposed to use. So the government has procured tools and is in the process to make sure that all tools required are present. And in 2025, we had no any ports which was certified by WHO. So we had to work closely with our country office, World Health Organization. The ministry worked with both ministries from mainland Tanzania and Zanzibar to organize a comprehensive training on ship sanitation inspection and issuance of ship sanitation certificate. We had to run into almost 3 phases, whereby we started with an online training course, which I think is included. I think this is a WHO platform where participants register and they complete the training and being awarded online certificates. And those who qualified for the online training, then they were included to the second phase of the physical training. In this case, because we have a number of facilitators at country level, we had to run the comprehensive training of more than almost 7 days at country level to make sure that they are trained on the theoretical part, but also on the practical part on ship inspection and issuance of ship sanitation. And lastly, we had also a physical training which was now by the international facilitators who were organized by WHO. And then I think you can see in this picture, this is a picture which shows when we had a physical training of engaging, involving our international facilitators. We really recognize and appreciate their expertise. You can see, I think they are very happy because I think they found that the Tanzanian team was very cooperative, and they were happy that the background training which we did was also helpful in terms of the training which also they had to do. So it enhanced their skills, and they gave us the exam, and the majority of our participants, almost all of them, passed the exam to qualify as inspectors. You can see these are some of the pictures when they were doing this physical training, which involved the theoretical part of it, but also the practical part of it. You can see the facilitators explaining on how to do the inspection in ships, and what are the things which you need to make sure that you pay attention on. But also, you can see this another picture that inspectors also need to have personal protective equipment. So you can see we observed that even during training, whereby we had our officers wearing the safety helmets and other. They also need some safety boots and other things. So this is something which even other countries, if you are planning to do this kind of training, you need to make sure that also you organize issues around the personal protective equipment. So in a nutshell, our training covered around 45 port staff from our ports, mainly Dar es Salaam, which is the largest one, but also have other Tanga, Mwanza, Mtwara, and Kigoma in the mainland, but also have Malindi, Wete, Wesha, and Mkokotoni in Zanzibar. So these ones which I have mentioned, they have already been equipped with tools and supplies to enable them to conduct the ship sanitation inspection and issuance of certificates, be it exemption, be it a control certificate, but also the extension certificate. We need to appreciate WHO. They were very quick in terms of application and approval to include now the Tanzania ports within the list of authorized ports to issue these certificates. So on 23rd January, that's when we are certified officially. And when you go to the website, you can clearly see that these are the ports which you can get the services. So as part of making sure that we standardize the services, the ministry has developed a standard operating procedure for ship sanitation inspection, taking much of the content from the guide from WHO. So we made sure that we customize and make sure that the inspection should follow that SOP, and the SOP is already approved and it is in use. And we can confidently say that 8 of our ports from Tanzania mainland and Zanzibar, they are listed to issue ship sanitation exemption certificate, but also ship sanitation control certificate. And we have 16 which are they can only provide extension certificates. But we need to also note that inspection is part of our routine work. So all ships arriving in Tanzania, they are inspected as part of ship clearance, and they are issued the free pratique upon satisfaction that there is no any public health risk on board. So we run both domestic and international ships. We need to make sure that they comply on sanitation standards. And meanwhile, because we have started very recently, but Dar es Salaam ports has successfully inspected and issued ship sanitation certificates to 2 international ships, and like some pilots. But I think we are progressing very well for other ports to implement as required. So these are the pictures showing those ships which were inspected, and the officers were inspecting different functional areas, as being the way that you have been trained in this webinar, where you need to make sure that you inspect all the functional areas, if it is the galley, if it is the store, if it's the engine room, if it's the medical facilities. We make sure that every area which the facilitators are training here, you need to make sure that they are inspected and they are in compliance. Maybe for your knowledge, this is a model of our ship sanitation certificate for Tanzania mainland. So we have 2 types of model. You can see the certificate having written the United Republic of Tanzania, Ministry of Health logo, but also we have a certificate with the logo from mainland Zanzibar. So all of these certificates, once they are issued, they are valid certificates. So as part of also the part of engaging stakeholders, we have run the meeting with marine stakeholders to make sure that we disseminate information on the procedure of ship sanitation inspection, but also we are starting the online training for other 136 port SC staff through WHO online course on ship sanitation. And as part of capacity building also, we have organized a short course training on vector control using the guide on vector control handbook of 2016, whereby 60 staff have been trained on vector and vermin surveillance, covering the 400 meters recommended by international health regulation. So this is the picture showing our staff also being trained on vector mapping. You can see they are doing some kind of the scooping and making sure that they identify the type of mosquitoes, type of vectors which might be present within the perimeter of their ports. For challenges, we can say 45 staff are still very few people. So we need to extend more training to make sure that more staff are trained on ship inspection, because we offer services 24/7, including weekend, and we are in the process of upgrading our porters surveillance system to have a landing website, which will also have the information for requesting for the ship sanitation services. And the future plan is that we are planning to officially launch the ship inspection services in the country. We continue mobilizing resources to conduct more training for more staff. But as I said, upgrading our website to make sure that information are available, but also making sure that all the necessary equipments and supplies are provided to all the ports. Want to acknowledge all of these for making this happen. I thank you very much for your attention.
Thank you very much, Remedios, for your presentation. It was very insightful to learn of the best practices, challenges, and plans for Tanzania. And next, I would like to invite Yaya to the floor to present on food safety.
Hello, everybody. First of all, I would like to thank all the colleagues from the Tanzania. I was in this Tanzania ship sanitation training last year with Mr. Rashdi from Morocco. Yes, we had a good time because all the participants are very eager to learn, and all the colleagues are very collaborative in this training. And I am happy to learn that Tanzania authorized their ports and they start to issue ship sanitation certificates according to IHR framework. After that, let's start the food safety issue on board ships. In this presentation, we will talk about some specific areas related to food safety on board ships, such as galley, storage, maybe service, food handlers, and how we inspect food areas and some main risk factors and hazards in relation to food safety. There are a lot of hazards in food safety. These can be chemical hazards or biological hazards like bacteria, virus, or some other risks coming from the equipment and the utensils. Yesterday we will talk about the all hazard approach. You know, you may remember that. It is a good example because some chemical materials, some natural, some other aflatoxin, maybe shellfish toxins, or cleaning chemicals or pesticides may provide chemical hazards to the ships and to food areas. It's a good example to necessity of the all hazard approach. And there is another good beneficial WHO guide to ship sanitation. You can find many scientific information in that guide about food safety, water safety, and the other issues. The first thing is to have a good food supply for the ships. It is important because ships navigate among many ports, and then they visit a lot of ports, and they provide their food supply from different supplies. So it poses a kind of risk. For that reason, ship staff, food handlers should be very careful about accepting this kind of supplies. They should have food supply in a good condition and from the safe sources. For the storage area, we have some important sanitation standards for the storage area. For example, materials should be clean and durable, or storage area should have ventilation, good ventilation and lighting, have a good drainage system, or adequate cleaning and maintenance, proper packaging, and they should have ships should have different storage areas according to the ships. Some small ships may have some two storage for the dry and cold, but the big ships have more than two storage areas. For example, for one storage area for the fish, one for the meat or other vegetables. And there is another rule advice should be obeyed. First out rule in the storage area. It means that first food put the storage area should be consumed firstly. We have some in our inspection. We see some problems in storage area. You can see the picture. In such a condition, it is not possible to have a sanitation in the storage area. Those storage areas should be clean, regularly organized, and they should have some storage equipments. What kind of problems we have in storage areas? Most of the time, food, especially easy to consume food, placed on the deck. We can see some vectors, fruit flies or some bugs, or improper storage of chemicals and cross-contamination. Raw foods and the food ready to eat can be together. And for the galley, there are some risk factors we have, such as the inadequate temperature control or infected food handlers. This is important. We will talk about that. And cross-contamination, heat treatment of the perishable food, or contaminated raw ingredients, and using non-potable water in the galley area. Equipment is important for the storage area and the galley area. Those kind of equipments like ovens, refrigerators, or washing machines should be durable, liquid-proof, smooth, stainless, non-toxic, and free from holes, and easy to clean. And food, we should some basic equipments in food area. At least, for example, we should have one dedicated to food handlers hand washing station. At least one sink for the food preparation, and adequate waste containers in the galley area or food area. And the facilities, I mean the galley facilities, potable water should be used in the galley, and sink drain should be indirectly connected to the wastewater to prevent the backup. And ships should have toilet facilities in a good hygiene, with soap and hand washing, hand drying facilities, and adequate ventilation and sufficient lighting. should be there in the galley area. Dishwashing facilities, at least one first aid box, and some temperature, one air temperature for the cold holding area, and one food probe thermometer in the galley, because we focused on the temperature, not only the surface of the food, but only inside of the food. For that reason, we use one food probe thermometers in the galley area. Toilets are very important because in many of the cases, communicable diseases coming from the food handlers to the food and to the other crew. For that reason, toilet, hand washing, soap is very important. Personal hygiene is very important in the galley area. Those toilets should be in a good condition and shouldn't be opened directly into food area, and the toilet area should have a good ventilation. And in the galley area, ventilation is again important for the to prevent the excessive condensation, to control the humidity, and the sufficient lighting and protected lamps, because maybe lamps can be broken and fell down to the food. And food processing. In the food processing, there is some sanitary conditions or the rules. The hand washing is important for the galley. It's also important in everywhere, you know. And discarding expired, spoiled foods in the galley. Monitoring temperature is another important issue in all food-related areas, because the inadequate temperature is the main source of the risk in the food area. Cleaning is important. All the surfaces and equipment should be clean after each use, and maybe they should apply disinfection and the vector control measures, because the food area attracts the vectors. And a good waste management is necessary for the food areas. Cross contamination is important. For that reason, the separate utensils and cutting boards and knives should be used for the raw food and ready-to-eat foods. Temperature control, I already mentioned that very important, especially for the storage area and for the ready-to-eat food, perishable foods should be stored at maximum 4 hours. In these 4 hours, they should be consumed, eat. Waste management, another issue. There should be enough containers, waste containers, and they should be closed in those areas, because the waste attract all kind of vectors. For the food handlers, two points are important. Food handlers should have enough information, enough knowledge about the food hygiene, personal hygiene, public health risks, and some communicable diseases, and they should have some actual practice, such as the hand washing, or they should have a specific clean, light colored clothes, the cover hair, and use of gloves, or do not smoking in the food areas. There is a concept or system in food areas, not only on board ships but on the shore. It is a global system, HACCP system, hazard analysis and critical control points. Most of the food catering service, for example, or the big ships, cruise ships, use this kind of HACCP system. This is focused on the monitoring the critical control points and implement some corrective actions. Ship inspector must be familiar with the hazard principles and some of those documents. For the inspection of the ships, actually it is not easy task to inspect the food area, because the food area is a big scientific issue, and there are a lot of things should be considered. But in general, an inspector should overview the construction, overview the ventilation, lighting, cleaning, toilet facility, or first aid box, waste management, pest management issue on board, and the storage of the hazardous chemicals. It is another important issue. They use the pesticides and disinfectants, but they can storage those hazardous materials together with foods. And inspectors may check all kind of documents, for example, clinic logs, temperature records, or food handlers training records, or other HACCP, for example, records. In our handbook, WHO handbook, you can see some of the inspection areas: construction, storage, training, food processing, hygiene control. You can see there are a lot of issues should be checked, but we have a limited time for inspection of the food area, so we should have enough experience and knowledge to make a good inspection. In a small, in a limited period, I am trying to explain the food safety issues on board ships. Thank you for attention and for listening. Over to you.
Thank you so much, Yaya, for a very informative presentation. Next, I would like to invite Dr. Rashti Abdurrahim to talk to us about medical facilities and medical waste.
Hello. Hello, everybody. I have a pleasure and honor to participate with you in this webinar, Ship Sanitation Inspection and Issued Ship Sanitation Certificate. So, following the previous presentation, this session focused on one of the key area of ship sanitation inspection as defined in WHO Handbook for Ship Sanitation. So, is the medical facilities on board the ship. According to the WHO, medical facilities must be designated, also equipped, operated, and maintained in a manner that prevents spread of disease and also ensure appropriate management of public health events during international voyage. So, continues with the competency required for ship sanitation inspection. In accordance with WHO, a health officer inspector must be able to apply basic epidemiologic principles to identify and assess public health risk on board. So the basic epidemiologic is very important for the inspector to develop, to make a sure assessment risk and implement surveillance for disease. The very important skill that's knowledge for basic epidemiology. Also, the inspector must and conduct a ship sanitation plan inspection focused on inspection, prevention, and control. Also, to have the competence to verify the existence and implementation of documented procedures and management plan for prevention, detection, and control of communicable disease. So documented the procedures is very important for this area. The inspector must also to have a capacities to assist medical care arrangements on board, including isolation procedures and alert mechanism. So next slide, we will continues to clarify the role of medical facilities in public health. According with WHO handbook, medical facilities are a key component of disease surveillance and control on board ship. However, normally, poorly designated or inadequately maintained medical facility might themselves represent a serious risk for communicable disease. For example, a sick passengers or crew member may pose a public health risk both on board, also at the shore. So for this reason, the physician, or doctor, nurses, or designated crew member responsible for medical care play a critical role in, first, early detection of disease. So early detection for disease can help all inspector or crew designate to facilitate early assessment risk, to implement control measures, including isolation. The first measures in medical facility in event, so the isolation cases. Also, timely notification for public health event to the competent authority is very important, the timely notification. The health inspectors must also have access to familiarize with operational manual and protocols to facilitate diagnostic and treatment. The handbook emphasizes that medical facilities requirement depend on the type of the ships, the number of passengers and the crew, the duration and the international nature of the voyage. So all the 3 points very important to help you to the medical facility size and other necessarily. For the very important legal framework in this slide, so very important in this area and in all area, the inspector health officer must to have a good knowledge in the international regulation and convention. WHO handbook for ship sanitation implemented within the framework for the international health regulation, which aim to the objective for all those regulations, so the handbook, HR or others conventions, so to prevent the international spread of disease and detect the response to public health events, also to ensure that public health measures are proportionate and risk-based. The handbook is completed by relevant instruments of the International Maritime Organization and the International Labor Organization. This International Labor Organization is very important in this area facilities, medical facilities, including the Convention MLAC 2006. This convention is very important convention. It's a crucial international legal instrument for seafarers in working condition at the ship. Also this convention MLAC 2006 protects their fundamental rights on board ships. Medical facilities, the health inspector has two important reference documents. So the health officer must know those important documents in inspection of medical facilities in the ship. Those documents, the International Medical Guide for Ships, EMGS, that you see at the back photos, also the medical first aid guide for using in accident involving dangerous cargo, INFH. So all cargo containing the dangerous cargo must to have this medical first aid for dangerous cargo. We continue the presentation, but the important constrictions for the and light of medical facilities. So some characteristic according with WHO handbook, the medical facilities must be easily accessible and separate from others activities, facilitates private treatment for ill person, be clean, will ventilate. For this ventilation on passenger ship, medical rooms and isolation area should have ventilation system independent for the general ships ventilation. So to reduce the risk of disease transmission, especially for isolated room. Example, a lot of example in the pandemic COVID-19. Medical facilities must not be used for no medical purpose. In our routine inspection, we found it medical facilities used for rest or for other thing, for store or something like this. The WHO handbook highlight that facility design vary dependent of ship size. So the small ships, not like a big in medical facilities. Ships type, cargo, passenger, cruise, operational, and voyage pattern. All those points make the size of medical facilities. We continues under medical facilities by the medicine and medical equipment. In this slide, we will clarify the regulation about medicine and medical equipment. All those must comply with EMJS recommendation or flex requirements. Also, flex requirement independent in this area. Meet MFEG requirement with dangerous cargo arcade. All ships taken dangerous cargo must have MFEH. Also, key inspection points include availability of required medicinal equipment, absence of expired medicine, also storage condition in accordance with manufacturer instruction. Very important, this issue. Proper organization and documentation of medical checks, availability of written medical procedures, appropriate level care provided on board, maintenance of medical devices in line with manufacturer recommendation. In the pandemic COVID-19 and after pandemic, the responsible of ship take more attention about personal protective equipment, because in our routine inspection before COVID-19 we found some equipment, but after COVID the ship with must more equipped by this equipment. The W handbook note that the images provide an indicative list of medicine. So for the ship taking dangerous cargo, have mass list of medicine necessary for this area. Please note this. Yes, we will to project two photos. One for a well medical facility, well organized medical waste conform with regulation. Other is the plan for medical facility. We can find in two important questions. So can reach emergency. The first question, can you reach the emergency equipment and medicine without leaving the patients? Other questions, can you enter with horizontal stitcher? So to manage the good medical facility, this plan is very important. We continues with the medical. Next slide, please. Medical supplies. This additional with the medical facility. Medical supply include all medicine, personal protectors, equipment, medical devices, and disinfectant sufficient to diagnose, treat, and control public health risk according to the ship size, number of travel, and voyage pattern. The supply must meet the recommendation and the requirement of the two documents important that we are speaking, EMJS and MFEAG as minimum. For next slide, for medical log record and communication, a very important document in medical facility. This is medical log, very important document for surveillance and prevent the spread of disease. Is a medical log identified by tool for disease surveillance on board, epidemiologic investigation, assessment of public risk during inspection. On passenger ship, additional disease-specific gastrointestinal illness might be. So for some passenger ships, cruise ships, you found that additional disease logs like gastrointestinal log illness or influenza log. In cruise ship, the medical logbook more professional. So medical log between containers, car carrier, passenger ships, and cruise ships is more developed. So for cruise ship, the medical logbook more professional, more developed with an electronic medical database for all passengers and crew. Also, we can have more information. Medical log must be well organized, legible, and updated. The medical log must list cases of illness, passenger, and crew concerned, and any medication dispensed like log entry should include those information very important in our routine controls for assessment risk and to implement the control measures. So first date of clinic visit, name, age, and sex of patient or crew designated, crew member position or job, because crew member or passenger ill person in assessment risk, crew member can have a lot of contact, can cause a lot of risk for in disease, in any disease. Also, the symptom details of specimen collected or other action taken. Some ships have detailed specimens, that's the quick test like COVID, influenza, Legionella. We finish with medical facilities on board ship. So now we continue with management of medical waste on board ship. All area at the ship produce the waste, but medical waste themselves can represent an important risk for communicable disease if no well managed. So we must have good knowledge for medical waste management. The management of medical waste on board ship is regulated by several international regulation and convention. IMO, WHO, including the MARPOL. MARPOL, very important convention in this area. Specific Annex 4. This convention must be reviewed by inspector. Very important management procedures for medical waste must respect separation and storage, labeling and identification, onboard treatment or disposal assured depend on the procedures on ship. So those management, separation and storage. We start with separation and storage, continues with labeling and identification, finish with treatments. The treatments are on board or disposal assured. Well, according with WHO handbook, all time we will to be according with WHO. Medical waste may contain infectious agents, hazardous chemical, sharp or cutting objects. Improved management of medical waste represent a direct risk to the crew. It's normal, and also for poor worker and environmental. Ships must therefore have documented procedures for the safe handling, storage, and disposal of medical waste. For a perfect management of medical waste, we must to know the categories and specify of medical waste. We have two categories of medical waste. We have the infectious medical waste and non-infectious medical waste. To make a good management, you must to know the categories of the waste. Medical waste management for infectious waste may contain infectious agents, hazardous, chemical, sharp. All those represent a direct health risk to the crew, to port worker, and environmental. So we must have be safely stored or sterilized and suitably packaged for ultimate disposal ashore or treatment on board. Only sharp must be collected in plastic autoclavable sharp container and retained on board for ultimate disposal ashore. Liquid health care waste might be disposed of by discharging into the sewage system. Liquid health issued for medical facilities. For the infectious, non-infectious waste, medical waste might be disposed of as a garbage if does not request steam sterilization or special handling if it not contaminate. So in this slide, we will highlight the key requirements for safe medical waste management. So medical waste should be equipped with appropriate waste container and bag holders, visible and restriction for waste segregation and identification. Container and bag should be removed when they are approximately 3/4 full. Sharp must be disposed on the container that are rigid, puncture proof and impermeable, like the photos in the yellow colors, labeled sharps marked with biohazard symbol. Pharmaceutical waste, including expired medicine, should be stored separately and returned to authorized ashore for disposal facilities. So for the management treatment of medical waste depend, so the treatment on board, like incineration or sterilization, or disposal ashore with respect on board procedures and country regulation. We must not forget a very important regulation in our routine inspection in this area. So each ships with 400 gross tonnage and above and certified to carry 15 person or more, a garbage record book and garbage management plan are mandatory, obligatory with all information including for management. Those documents must to be inspected and controlled in our inspections. We continues with the document review. During inspection, the following documents are reviewed as applicable. Update, ship's log or medical logbook, current reviewing log are not available or incomplete. Also, maritime declaration of health, training record and certification of personnel assigned to medical care crew member designated for this activity, list of medicine, disinfect and disinfecticide, cleaning, disinfection, maintenance and waste management procedures. This is surveillance log for the ship, passenger ships or cruise ships. Also operational manual for high-risk medical facilities or devices. If we have specimens collected and test results if the disease event occurred on board, international certificate or vaccination or prophylaxis if available.
Hi,
So,
Rashid. Sorry to interrupt. I wanted to see if you can possibly wrap up in 3 minutes, please.
yes, I finished. So the technical area for this area, so medical facility area 5 and medical waste area 7.
Perfect. Thank you.
Thank you very much.
Hi, Rashdi. Just to confirm, have you concluded your presentation?
Yes, we have just, if you have 2 minutes.
Okay, yes, yes. Please go ahead. Thank you.
Okay, thank you very much. We can continue with some small exercise. Next slide, please. Okay. In this photo, we have the medical facility using for storage. So normally, medical facility must be not using for the storage. Next diapo. Next slide. So in this slide, absence of or inadequate sharp of medical corrector. Normally, you must to have equator mid united nice and sharp for biomedical collector. Next, medicine not stored according with the manufacturer. So store medicine must to be according with manufacturing requirement. In summary, medical facilities involves an assessment based on the WHO ship sanitation inspection, ensuring that the inspection and evaluation follow international standard for ship medical facilities and public health safety. with easy accessibility, privacy, lighting, ventilation equipment to confirm that medical facilities are safe. The review also covers record logs and communication system which are essential for disease surveillance, reporting, and coordination with medical authorities. Thank you very much for your attention, and I am available for any clarification or question.
Thank you very much, Rashdi, for your presentation on this very important topic. So I think now we will have a pop quiz, a poll question, before we move on to the next presentation by Martin. So you should be seeing a question pop up in front of you on assessing medical facilities. We will leave the question up for about 30 seconds. Okay, we've had more than 100 responses so far. Just a couple more seconds. Okay, great. We are at about 50% response rate, and I will end the poll now. And Rashdi, if I can invite you to let us know the correct answer, please. Oh, I'm afraid you're on mute.
Okay, perfect. The second is the correct answer: layout, accessibility, ventilation, equipment, waste management, and all those all those aspects on board medical facility very important and not easy to evaluate. So we need a lot of knowledge, capacities, and the training for this area. Thank you very much.
Thank you very much, Rashdi. So next, I would like to invite Mr. Martin Walker to tell us about potable water and water sampling.
Good afternoon, Supriya. Can I just check? Can you hear me? Okay.
Yes, we hear you.
Good, perfect. I just have a little problem at my end in that I cannot see anybody, any of the smiling, happy participants at my end. Unfortunately, I've got a blank screen, so I'm going to try to work from sharing my slides at the WHO end. And is the presentation?
It is up now.
Okay, so
Yes.
I'm not seeing that at my end, so I'm going to go from my own presentation.
Oh, I'm sorry, Martin. I think the connection is cutting in and out.
Okay.
It seems to be better now.
Yes, I'm getting low network bandwidth. What we call here is Suffolk Internet. The area where I live is Suffolk, and it's notorious for being a little bit limited on the technological front. So hopefully it will hold up. Is that okay at the moment, Supriya?
Yes, we are seeing the first slide of your presentation with the title Potable Water. So if you'd like us to advance, please let us know so.
Yes, please. If we move to slide 2, please. So WHO has really set me up. They often set me very difficult challenges, which I hopefully rise to. This time I think they've set me an impossible challenge to go and talk about potable water in 15 minutes, but I'm always up for a challenge, so here goes. It's the area that probably, because it's housed within the engine room, is one of those that sometimes seen as mysterious by a lot of port health officers. It is an area that is of great importance on board ship. And it is probably also an area where we find some of the most significant problems and areas needing rectification. So within 15 minutes, I will try and give you a very brief overview. I hope to inspire you to just challenge yourself, go down there, find out more about the systems, have a greater understanding, ask lots of questions, and really start to build up your knowledge and confidence in relation to this area. What I need to start with is, what is potable water? And our good friend, the WHO Technical Handbook, is very helpful in this respect. In the narrative of Area 9, it sets out that potable water, also known as drinking water, means any water for human consumption. Now, first part of human consumption, drinking, is going to be fairly obvious, hopefully. But the definition is extended to include cooking, brushing teeth, showers, washing hands, washing clothes, etc. So that is the WHO definition of potable or drinking water. The definition of fresh water, which ships will often refer to and sometimes may confuse the two definitions. Fresh water is actually untreated water, or water that's perhaps not intended for human consumption purposes. So at the point at which fresh water is treated, it then becomes potable or drinking water. So the two definitions are very important to understand. If I move on to the next slide, please. Now, this is where it starts to get more complicated. I personally love going down to the engine room. That's my favourite habit, my favourite haunt. So I'm always saying that that's where you'll find me at my happiest, because I find it particularly fascinating, the different systems that are on board there. Ships' water systems, particularly for potable and freshwater systems, share a lot of commonalities and a lot of common components, but they can vary substantially according to individual vessels and how they actually manage their particular systems and have them constructed. So always trying to understand them and get to know them is the biggest challenge, first of all. But with experience and with going down and asking the right questions, you will improve your knowledge and understanding there. And that's essentially how I've had to learn how to do it over the years. For the schematic on the slide here shows a typical potable water system on board ships. In this case, the two main areas by which ships supply themselves with water are firstly by bunkering, either directly from the port or perhaps indirectly via water boats and water barges. And the second major source of water is actual water production on board. Schematic also shows other stages within the potable water systems that are typically generic. So the treatment section, followed by storage in potable water tanks, finally distribution around the ship for its various purposes. So it's a very broad schematic. What I would say is that in order to fully understand ships' water systems, good tips include speaking to the engineer, getting them to explain exactly how they work. I will routinely now ask for schematics or piping diagrams of the ship's water systems to help me understand how they're set out. Some of them can be relatively simplistic. Some of them are much more detailed and quite complicated as well. But either way, with the engineer, you can start to work through and get to understand the systems. And understanding the systems is then key to being able to determine whether there are any potential problems that might need your intervention as a ship sanitation inspector. So ask the engineer, get them to explain, and they're usually very happy to do that because they don't get very many visitors down in the engine room. So if you go in there with interest, they'll probably really open up and assist you quite substantially. Next slide, please. So again, you will have copies of all of these slides. I just want to focus in on some of the detail behind some of the other areas. So treatment of fresh water in order to make it potable water can include various different processes that are listed there. We will focus on the public health side, particularly on disinfection, but the other elements are important in the overall picture as well. So filtration, remineralization, heating, etc. We'll also quickly have a look at distribution and the features of those. Next slide, please. This is a schematic showing basically what was shown on the very first slide, breakdown of how bunkering takes place. Bunkering, you have to be specific that you are talking about bunkering of fresh or potable water. Typically from ports, it should be potable water. It should have been treated if it's been supplied directly to the ship. But bunkering can also encompass other operations, such as bunkering of fuel, bunkering of oil, etc. So you have to be very specific that it is the water that you're interested in. Next slide, please. As we said earlier, the other main source of water on board is production. That's going to be usually by two main methods, through reverse osmosis plants or by the use of evaporators. Usually, whilst you can have either in any type of ship or sometimes both, most frequently reverse osmosis plants are more typically found on board cruise ships, and evaporators more typically found on cargo and container ships. The essential operation is that you are transforming seawater into drinking water by removing the salt and then treating it, adding minerals to make it suitable for drinking. So that's the primary role of production water on board. Next slide, please. So mentioned two typical sources. I want to look at these in a little bit more detail and show you typically what these pieces of equipment look like. Evaporators are very common on board cargo ships. You'll sometimes find them on cruise ships, sometimes in conjunction with the reverse osmosis plant, but virtually all cargo ships, evaporators are the go-to means for production of water. So seawater is heated, usually by excess heated water from the engine, so they will not be operated whilst in port because typically they're not using the main engine at that stage and therefore not generating enough heated seawater. Or the vapor is then generated as a result of that heating process and condensed within the evaporator so that it separates out the distilled water or condensed water, which is collected in the tanks, and then a very concentrated brine solution, which is separately collected and discharged usually into the open ocean. The evaporation process can take place at high temperatures, but often will be much lower than 80 degrees centigrade because these evaporators will operate under vacuum, and therefore, just like if you climb Mount Everest and the pressure is reduced, the atmospheric pressure, water will boil at a much lower temperature. The same principle applies in these evaporators. And you can see a couple of pictures there, one of the exterior at the top of a typical evaporator on board a cargo ship, and then what it basically looks like inside with the evaporation plates on the lower part, and you can see they've been taken out for maintenance. On the upper part, on the spigots, those metal evaporation plates are in place for the condensing, where the cool water is passed through. If they operate at less than 80 degrees centigrade, you are not getting any thermal disinfection, and therefore further disinfection by whatever means is certainly required. Next slide, please. The alternative method is reverse osmosis. And there was a question in the chat yesterday, will we cover this? I will do very briefly in the time that's allowed, but the principle of reverse osmosis is that, again, you are basically turning seawater into water that's able to be drunk. Osmosis takes place under pressure. Typically, if you have a tank with a semi-permeable membrane between a low concentration solution, so water that contains very few salts, and a high concentration solution, so seawater that contains a heavy concentration of salt, through that semi-permeable membrane, the higher concentration solution will draw the lower concentration through that membrane by what's called osmotic pressure. You can reverse that process, hence the name reverse osmosis, by applying a high pressure to the high concentration solution, as the diagram shows there, which then pumps the water from the salt water into the low concentration solution, but doesn't allow the salt molecules to pass through. So you end up with produced water which is desalinated. You'll still need treatment, but by applying that pressure to the salt water, then you can create fresh water from there. And that process, because you're reversing the normal osmotic pressure, is known as reverse osmosis. And the picture underneath the text there shows what a typical reverse osmosis plant will look like. You will not see the innards of that because it's all contained within those cylinders. Next slide, please. Talked about the other aspects of treatment. In the limited time that I've got here, all I can really say is that filtration is necessary to improve the clarity of the water. Typically, it could be sand or cartridge filters. As with any component of the potable water or freshwater systems, cleaning and maintenance is absolutely key. So the ship needs to demonstrate that they're carrying out the cleaning and maintenance as per manufacturer's instructions or other technical standards, and that can be part of your checks. Next slide. Remineralization. The problem with desalinated water is it's often bland and does not taste very, very good. Therefore, you need to re-add salts back into the water to make it palatable, but it also has the additional benefit that it will, through this process of rehardening, it will make the pipes, it will make the water less corrosive and harsh to the pipes. Next slide, please. Disinfection is absolutely critical in order to convert fresh water to potable water. There's a range of different systems on there. This slide and the picture shows a typical automatic chlorination point. It is essential that ships have their necessary consumables on board, so the relevant chemicals, sodium hypochlorite, a base to neutralize or lower the pH, because it needs to operate at less than pH 8 in order to be effective. Typically 7.2 to 7.5 is the ideal. Next slide. Chlorination is one, UV is probably second most common, and certainly on cargo ships relies upon water being ultraviolet light, so the water has to be extremely clear in order that the UV radiation can inactivate the pathogens and it can pass through the whole of the body of water that's going through there. So typically water will need to be filtered before it goes through the UV tube. Important to note, if there's any contamination that happens after that disinfection, there is no residual disinfection. So it is a one-time disinfection only. Next slide, please. Storage, you typically will not be able to see too much from the visits to the tanks within the engine room, but this is a cutaway showing the usual makeup of the potable water tanks, or if they've not been treated, they may be referred to as freshwater tanks. So some of the common features are the actual inlet at the top, the outlet towards the base, but not entirely at the base for distribution, because you'll need to have a drain to let out any solids that might have accumulated there, and also a vent which is properly screened to prevent any dust, particles, insects, etc. And you can typically see those on board the deck if you go to the potable water tank vents. Next slide, please. Very quickly, the distribution relies on a system of pumps, and the pumps provide the pressure to circulate water around the system. But because you can get variations in that pressure and you need to ensure that the pressure is constant, another key component are the hydrophores that buffer small pressure variations and provide constant pressure around the system. They also have to, as with every other item within the system, be properly maintained and alternated if you have dual systems, dual pumps, so that you don't get stagnant water buildup. Next slide, please. I will just say on this one that plumbing, hopefully we don't have any lead or cadmium pipes left on any ships, but it is certainly a possibility on some very old historic ones. You will have copies of these slides, so I don't want to spend too much time just repeating what's on there. Backflow prevention, sorry, that's the next slide, slide 16, is very important in order to stop potential contaminated water where it hits a blockage being pushed back into the system and introducing contamination from another source. So it is a specialist area in itself, and it's one that I would encourage you to try to get to learn. It is a key component of the water systems, and you see different examples there on the pictures. The top one shows a mechanical backflow prevention slide where the normal flow is from left to right. It flows through an angled area where a flap or valve is. If there's any pressure to push the water back the reverse, that pushes the flap closed, and then the backflow is stopped. An air gap, which is the type shown on the bottom picture, works by, if there's any overflow, that will overflow back through the sides rather than back up through the pipe. And that, if we move to the final thank you slide, is a very brief introduction to the world of potable water systems. I hope it's been useful. I hope it will inspire you. I would say Possibly, if it would be benefit, please suggest that it might be a topic for a future EPI-WIN webinar. And at that, I will say thank you and hand back to the host.
Thank you very much, Martin, for the suggestion and for living up to the challenge that we have given you despite technical difficulties. So thank you very much. With that, I'll hand it over to Sarah for the discussion session.
Thank you. So colleagues, we know we are running a little bit late. We see that just like yesterday, we have a very proactive participation by all in the Q&A chat. So please keep sending your questions there. We don't want to run this webinar longer than we promised it would last. So we would encourage you to please ask the questions in the Q&A chat. We will continue answering them in there. We will also have a discussion, a short time for discussion in the afternoon. We can highlight some of the key questions that have come up then. But because we want to respect the timing of the agenda and go back on track, we will be doing now, instead of the discussion here verbally live, we will continue it in the Q&A chat. We are going to launch a poll question now, and then we will let you all go into your breaks and then resume to keep the timing of the agenda as agreed. So over to you, Sophia, for the poll question.
Sure. So I'm launching it now on potable water to see if you feel confident about assessing potable and freshwater system. And as usual, we'll leave it up for about 35 seconds. We're very curious to know how you feel. Few more. We have about 200 responses already. So I will end the poll now. Martin, are you able to see the results at all?
Yes, I can, Supriya. That's a fairly even spread. But if we take less than 5 or 6 being there, it's good to see that there is 20% with 10, 13 with 9. But I think there's the clear message there that additional support would certainly be welcome, and sometimes just the reassurance that you know what you're looking at is also beneficial as well. So, yep, that's probably a little bit more positive than I was thinking, but very, very valuable. So, thank you.
Thank you very much, Martin. And I think that speaks to the clear presentation you have given, which gave our participants the confidence. So with that, we will now go into break, and we look forward to seeing everyone back in 7 minutes. Thank you. Welcome back, everybody. I hope you had a very nice shortened break. To start off our second session, I would like to welcome Dr. Barbara Mushtori to tell us and speak to us about sewage. Barbara, the floor is yours.
Thank you very much. Sophia, let me share my screen. Great.
We can see your slide very clearly.
Great. Thank you. In an inspection for the issuance of ship sanitation certificates, of course, the primary objectives, the primary focus is sanitation and prevention of international spread of diseases. But why sewage is part of the inspection and should be inspected? We may have failures in collection, failures in treatment or disposal, and due to these failures, we may have significant public health risks. We may have untreated or poorly managed waste that may contaminate onboard environment surfaces and increase the risk of disease transmission. In addition, sewage discharged without proper treatment can contaminate coastal waters, aquaculture areas like seafood sources, and this can cause indirectly adverse outcomes in human health. It is also important to note that any findings related to environmental pollution should be communicated to the competent authority, such as the port state control. So we have the health authorities that inspect ships, and the primary focus is public health, but in most countries, we have other authorities that are responsible for environmental pollution prevention. If there are findings that should be shared with these authorities, this should be done. So the inspection in sewage
Barbara.
Yes?
Oh, sorry. I think your slides maybe were stuck, but I think we see them now. Advanced to learning objectives.
Okay,
right?
okay. Thank you.
Great.
Yes. So, I was telling that it's important if some findings should be shared with other authorities that are responsible for environmental pollution, this should be done. So the inspectors for public health and sanitation aspects should not focus their inspection on the environmental aspects, but more on public health aspects. By the end of this session, you should understand the standards for sewage management on ships, the public health reasons behind inspection and control measures, and the key sewage documentation that should be available on board. Now, the term sewage means actually black water, and this includes any drainage from toilets, urinals, WC flushing system, medical premises, spaces containing living animals, and other wastewaters mixed with the above aspects that I mentioned before. Grey water is used water, including drainage from galleys, dishwashers, showers, laundries, baths, and waste bins, basins, drains. This slide summarizes the basic requirements for sewage management on ships. In general, ships of more than 400 gross tonnage or ships carrying 15 passengers or more must be equipped, persons or more, must be equipped with an appropriate sewage system and at least one of the following options should be in place. First, a holding tank with sufficient capacity and a clear level indicator, or a comminuting and disinfecting system, usually combined with a storage tank and an approved sewage treatment plan. During inspections, it is important to verify not only that these systems exist, but also that they are functional, properly maintained, and used according to correctly to prevent health and environmental risks. Here we can see in this slide key inspection points for the storage tanks. The storage tanks should have basic safety features, including a level indicator, a high-level alarm, access for cleaning, an overflow system, and proper ventilation through a vent. It is also essential that sewage tanks are located in an isolated position. They should not share a common wall with potable water tanks, so that we can prevent any risk of contamination. Protective structures are important to be in place to control leakage or spillages. Safety barriers, some examples are safety barriers or raised edges that are used to prevent liquids from escaping. During inspections, these elements help ensure safe containment and prevent sewage from becoming a public health hazard on board. Many vessels apply biological treatment processes, such as an aeration tank, biofilters, or more advanced systems like membranes, bioreactors. Inspectors do not need to assess the technical design in detail, but it is important to confirm that the treatment plant is approved by the competent authority, properly operated, and maintained according to the ship's procedures. The key focus is always whether sewage is being managed safely and is in compliance with sanitation standards. Now that we have seen the different types of sewage treatment systems, let us briefly look at the typical stages of sewage treatment. This will help inspectors understand the basic processes that and what to check during an inspection. And this diagram shows the typical stages of sewage treatment on board. First, sewage is collected in a storage tank and passes through a screen, which removes larger solid. And next is the biological treatment stage, usually in an aeration tank, where microorganisms help break down organic waste. Then comes the settling stage, where solids separate from sludge, and which is removed for proper disposal. Finally, the treated wastewater goes through a disinfection stage, often using chlorine to reduce pathogens before discharge. For inspectors, the key point is to confirm that each stage is functioning properly and that treatment and discharge are carried out safely and according to the standards. Sewage on many ships is treated biologically under aerobic conditions, meaning oxygen is used to support the breakdown of organic waste. One common system is the aeration tank, where air blowers provide oxygen through aerators, maintaining the conditions needed for microorganisms to treat the sewage. A more advanced option is the membrane bioreactors. Another approach is the biofilter. Again, for inspectors that issue the certificates, the key, of course, is not to focus on engineering details, but ensure that these systems are approved, operating correctly, and properly maintained. In the settling tank, water is separated from solid matter. The solids collect as sludge at the bottom, and some of these sludge may be returned to the biological stage to support ongoing treatment. This step helps removing solids before disinfection and discharge. After biological treatment, the final step is disinfection to reduce pathogens before discharge. The most common method is chemical disinfection, usually through chlorination. In some ships, UV radiation may be used. For inspectors, again, the key is to confirm that the disinfection system is functioning properly and operated according to the ship's procedures. Two key pieces of information here are the discharge pump and the air blower. The discharge pumps ensure treated wastewater is transferred safely for discharge or storage, while the air blower provides oxygen for the biological treatment stage. During inspections, it is important to confirm that this equipment is operational and properly maintained, as failures can compromise the entire sewage management system. And this slide provides a practical overview of a typical ship sewage treatment system. And you can see the different compartments as we described them before. For inspectors, this diagram helps identify the key components and to verify the aeration, settling, disinfection, and the proper functioning of pumps and blowers. As we said, some treatment system may have membrane bioreactors. This must be approved. And an inspector can check if there is an approved system, and the approval usually is given by a flag state administration or a recognized organization that is acting on the behalf of the flag state administration. Now, there are some documents that can be reviewed as part of the sewage inspection. For a sanitation inspection and for issuing the ship sanitation certificate, the document review should focus on whether the vessel can safely collect, treat, and discharge sewage without creating public health risks. So there is a list in the handbook in the specific area of inspection of sewage that you can see the list of documents that can be reviewed. One of these is the IMO International Sewage Pollution Prevention Certificate that is valid for 5 years. And this can confirm that the ship's sewage system complies with the requirements of MARPOL. It is important to check that this exists, it's valid, and that it is supported by proper maintenance and operational records. This slide summarizes the main rules for sewage discharge according to MARPOL. So if sewage is discharged without treatment, it should only occur at least 12 nautical miles from the nearest land. If the ship has a comminuting and a disinfecting system, discharge may be allowed at least 3 nautical miles from land. When an approved sewage treatment plant is operating properly, discharge may be permitted more broadly in accordance with regulations. For inspectors, the key is to confirm that discharge practices follow the required distances, systems, and documentation according to the rules applied for this specific ship. This slide highlights 2 key inspection areas. The documentation, the certificate actually, and the piping. Specifically, the piping should be checked carefully. Sewage pipes should be clearly color coded. For example, with black, blue, black markings at regular intervals. Inspectors should also look for any potential cross connections between sewage lines and other systems, especially potable water, as this could create serious contamination risks. Here we summarize key inspection points for sewage holding tanks and treatment plants. For the sewage holding tank, inspectors should confirm that the tanks is clearly identified, the capacity is labeled, and the high level alert indicator is in place to prevent overflow. For the treatment plant, it is important to verify that disinfectant is available when required, especially in the comminuting and disinfection systems. Inspectors should also identify sampling points, understand how the system is cleaned and disinfected, and check for any potential cross connections. And finally, valves should be clearly marked so the tank, treatment plant, and the discharge lines can be isolated when necessary. Thank you very much for your attention.
Thank you very much, Barbara, for a very informative presentation. Before we move on to the next presentation on vector control on ships, this is just a gentle reminder for all speakers to stay within the time frame to be able to finish on time. So thank you very much for that. Let me now welcome Dr. Rashti Abdul-Rahim back on the floor to tell us about vector control on ships.
Thank you. So we start with the vector control on ship. The vector control represents a significant public health risk due to emergency or emergency vector-borne disease. A regulatory obligation requiring strict compliance with the international regulation. Also, vector control on ship represents an operational challenge for port authorities and for public health. In accordance with WHO handbook, a health inspector must be able, next slide please. A health inspector must be able to understand the relationship between the HR and vector control on a ship. Also, the inspector must know the health risk associated with the vectors, the role of vector surveillance and control. Also, he must know the step to do on board inspection and suggested area to be inspected. To be able to verify the integrated pest management plan if has been implemented. So, the challenge and vector-borne risk for international public health. With the increase and the spread of ships movements, passengers, traffic, and the volume of trade, so all those favorite the rapid spread of disease like dengue, Zika, chikungunya, malaria. Also, pandemic risk by introduction of vector into no-endemic area. Vector-borne disease lead to high healthcare costs and disturb trade and tourism with important socio-economic impact. Next slide, please. The inspector must have a good knowledge in the legal format. So, according to WHO handbook, the area of vector control on board ships is covered by a several legal regulation and international convention, like WHO, HR, AMO, so a several regulation, maritime international dangerous good codes, maritime fumigation, so several. We continue in this legal framework by HR regulation. Next slide. Under HR, this area control vector on board ships have a several practice article like Article 20, 22, 24, 27, and others. And importance annex like Annex 3, Annex 5 with specify responsibility for each intervenant country, competent authority, responsible conveyors, and health authorities. So now we must know the health risk. In this area, we have two types of risk, health risk and environmental risk. Health risk in disease, like disease risk, directly, contamination directly, like disease, malaria disease, dengue, Zika, yellow fever, leptospirosis, or indirectly by contamination, food, stored food, or other goods. For the environmental risk, the very important environmental risk is the destruction of the goods on board the ships. Example, container invaded by pest specimen of organic matters. Example for Asia, gypsy moths. Other important problem, destruction of ship equipment and goods by rodents, some material damaged. I will to share with you in the last of these presentations one case study for the destruction of goods on board ship in our port and Germany. So now we must know the objective vector surveillance and control according to HR. After that, we know the risk caused by vector. We must to implement the surveillance to establish the control measures. So, what is the objective for vector surveillance? The objective vector surveillance is to prevent vector-borne disease, understand the range and importance of species bioecology, determine area and risk, and prioritize area of intervention. Also, to choose control methods. This is very important, this step, to choose the control methods depend any cases, any event. Initiates control operation, evaluates control methods. And the important objective of vector control is to reduce the risk of the spread of pathogen vectors and harmful vectors. Now we continue with the methods for controlling vector in the area most frequently contaminated by vector on board ships. In this slide, we will clarify some most places preferred by vector on board ships. So, like in the garbage beach, cargo hold, galley, bilge, toilet, engine room, lifeboat cover, mooring line, so a lot of places must preferred by vectors. We can find vector in other area. We will to continue the process by implementation the control measures. For control measures, all ships normally use the standard measures, basically like preventive, defensive, or offensive, to prevent the infestation by vector and vector-borne disease. In this slide, we will to highlight one of the important methods for control vector on board ships, the Integral Pest Management Plan. So, what is the Integral Pest Management Plan? Is a holistic approach to managing vector control on board ship. Integral pest management is an effective and environmentally sensitive approach to pest management that rely on a combination with common sense practice. So, this documented or recorded process of controlling vector on board consists of 5 steps. So, all steps for integral pest management must to be documented and recorded on log on board ships. The steps include the first, inspection and prevention to eliminate all factors that favorite vector presence. So prevention is the first step. Also, to follow this by identification by recognized type of vector and its biology. Very important, this step also. We succeed by establishment of threshold level, by defined tolerance level, employment of control measures by using all integrated control method, evaluation of effectiveness and monitoring. So I will present an example practice for integral pest management for mosquitoes. So we start this plan by prevention of access of mosquitoes to the ship screen, closing door, windows, ramps, cabin. After placement of light sticker traps close to the ship opening, including windows. So we must documented passive and active surveillance in the log response for this EPM. Elimination of standing water indoor and open deck. Availability of insecticide for commonly found vector on board, including mosquitoes. All ship must have sufficient insecticide. Recording of insect bait and complaint from travel. Evaluation of application of integrated pest management. We make assessment risk, identify assessment risk, make a control. We must to establish the evaluation and monitoring for application of integrated management and conducting integrated pest management inspection on board. After, we must ensure correct implementation of vector preventive measure. After evaluation, you must ensure correct implementation of vector prevention measure, sanitary standard monitoring procedures and documented system. The handbook for inspection and issued ship sanitation certificate. In this area is 13, area 13, other system and area. So we don't have in this area a specific area for vectors, but all area at the ship probably must be contaminated by vectors. We continue by inspection steps on board ships. Next slide, please. The same for all. Next slide, please. So the same for all procedures of inspection of any area on the ship. We start with control documents. So each inspection start with control document certificates, previous inspection report, very important, the previous to review the previous inspection report, and integral pest management. All ships must have the integral pest management. And we continue with the inspection area, galley, provision, bar, cabin, hospital, engine room, also to verify actual location or monitoring traps like in the photos. Ensure pesticides are not stored in food area and are properly organized and stored in a secure area. Ensure pest control supplies such as bait, traps, and spray are sufficient in order to respond to a possible infestations. Now, next slide, please. Now we will continue with one case study or really example for one container ships dock in Tangier made contaminated by vector. I will to share with you all steps necessary to detect, evaluate, and implement the control measure and their integral pest management. So the objective for case study, so they describe the entomological contamination observed on board a vessel. After you must analyze the vector control measures implemented, assess the compliance of intervention with the national and international regulatory framework, draw lessons for improving vector risk management in port environments. So the objective to share this case study. So description of the ship and the voyage. We can pass this slide. Next slide, please. So we start with inspection identification with entomologic and epidemiologic identification and investigation. Upon the ship berthing, we proceed with entomologic identification and sanitary verification. During the pre-arrival document check, no public health event were reported on board, so the master not reported in the maritime air declaration or by other system information that the ship was contaminated. The vessel was then authorized to berth and clearance was granted to start operation at the terminal. However, during the handling of cargo, stevedores observed a significant number of insect larvae on board, highlighting the need for further inspection and possible control measures to ensure sanitary safety. After thorough fending infestation on the ship by larvae, the vessel contaminated container with leachate and larvae, 15 containers containing organic matters, which caused the appearance of larvae, were unloaded. The ship's captain did not report the health event in accordance with the HR 2005. Next slide, please. So, after identification, preliminary evaluation, we must to implement the measure on board ship and ashore at the terminal. So, after detecting the infestation of unknown larvae on board the vessel, the border health control proceed with the following action. Conduct a thorough inspection of all hold to identify problematic container area, suspended unloading operation, placed the vessel under isolation, collected sample for larvae identification. Very important that step to collected sample for larvae identification. Must to have a great laboratory for this issue. Prepared a detailed report. The measure implemented ashore focused on routine returning the infested container on board to prevent the spread of the vector because the port is full with a container, as well as the immediate disinfection of the ship and the terminal. Next slide, please. So before the key point to take away from this case study. Before this, we have the laboratory result and assessment risk. We have the preliminary assessment now, so the end assessment risk. So we have the coordination meeting with all stakeholders for decision making after receiving laboratory confirmed that the result is larvae of the black soldier fly Hermetia illicensis. So the decision, the continuous action, the decision to clean, disinfect the ship and all contaminated container, issue of evidence report with red stamps in sanitation certificate with all measures taken on board ship, like the photos that you see in the photos. Next slide, please. I want to share with you the key point to take away from this case study. So include this key point, the importance of vigilance and event-based surveillance. So in Morocco, we were working with the event-based surveillance at all points of entry. The significance of multi-sectorial collaboration, necessity of cross-country cooperation for information sharing and coordinate decision-making. Finally, the captain's false reporting could have caused a critical incident. In conclusion, vector control at point of entry and on ship is crucial to protecting global public health. A combination of regularity framework, monitoring tool, and preventive measures is required. International collaboration and continuous monitoring are required to reduce health risk. Thank you for your attention. I remain available for more clarification.
Thank you so much, Rashid, for your very interesting presentation, especially the case study. For the next segment, we will just have a very quick poll, and I will invite you back, Rashid, to give the answer to the poll question. Okay, the poll has been launched. You should see it on your screen right now. We have about 100 responses so far out of 420. We'll give a few more seconds. Okay. We have about 220 responses, so let me end the poll here. And Rashdi, let me invite you back to let us know the correct answer. Thank you.
A perfect answer for 18%. That's the answer 3. So application of Article 27 under HR 2005 with sanitary inspection and control measure. So in our case study, I follow all those steps for declaration, identification, so isolation the ship under Article 27 ship affected ships, and we start with inspection, assessment, risk, control measures, and evaluation. Thank you very much for answer.
Thank you very much, Rashdi. Next presentation will be an interactive exercise. So let me welcome back Dr. Barbara Mushturi.
Thank you, Sophia. Well, let's now recap and let's practice inspection skills by looking at some pictures that provide evidence from inspections, and we can discuss together what are the risks, if there is any finding, what is the risk from this finding, what are the control measures, and most importantly, how we document the finding and how we link them with the WHO handbook for inspection of ships and issuance of ship sanitation certificates. So, for each photo, we need to identify the public health concern, the corrective action, and the applicable code in the handbook. Let's say that you are on board a ship, a passenger ship, you are in the galley, and you want to inspect the facilities for hand hygiene. Hand hygiene is very important for food safety, as we all know. Now, you see this. Please write in the chat box your opinion as inspectors. Can you see any inspection finding here?
We welcome all participants to provide any observations or opinions in the chat box. Please type your answer.
I can already see bin not covered, sink blocked. Okay. Difficult access, not hand drying facilities, hand washing blocked, sink is blocked, sink got blocked. Excellent. Very well. So if someone would like to wash their hands here, as you said, the access is not possible, or it's partially possible, and this can increase the risk for someone not properly wash their hands or not wash them at all. And of course, this can increase the risk of gastrointestinal outbreaks and especially transmission of pathogens that can be transmitted to food. And we know that on ships we have common food sources and we can have large outbreaks. So I can see most of you have identified this very important problem. Some of you, you write that there is no soap. Actually, it's not possible to see this from this picture. But we can say that they can remove any object that prevents people from washing their hands as a corrective action. And if you could see in the handbook what is the relevant code, it would be very important. Now we do not have the time, unfortunately, to do this, but if you see in the handbook all the items, you see that you can link this observation, this finding, with code 2.2.1. You can see here the recommended description of the finding, and then the corrective action. What is very important is to link all findings with the handbook. Now, you continue with your inspection and you are visiting the crew mess, the place where the crew members have their meals. And you see this situation. You see food displayed openly on a table like this. The food is not covered. Food is not covered, inadequate serving utensils, and possibly needs temperature control depending on time for service. Food not covered, no sneeze guard, very well. How long has it been there? Very well. Cooked food not covered. Spoon inside food. Uncovered trays. Temperature control failure. No food seals. Any flies present? No sneeze screens. Very well, very well. Very nice. So, we can see some things during our inspections, like this picture, what we see in this picture, but what it is important for us is to investigate, not to stay on what we only see. We need to make questions, we need to ask things. We need to identify if there is any food safety system in place. What are the procedures? What is the training? What is the purpose? How long, as you very nicely said, how long this food is exposed, why it is exposed. If there are people that are going to be served, then we need to see how the food will be served. Is there any person that will serve them while sitting, or this is a buffet area where everyone will go in line and will be served? So we need to investigate before we start writing our inspection findings. As you nicely said, we have cooked food stored and protected in incorrect temperature. We have food, we have room temperature here, of course. But for how long? We need to investigate this with logs, with interviews of responsible crew, with procedures, when the crew mess is open, when it's closed, etc. So we should not make assumptions. We need to investigate, to collect evidence, and then write down our inspection finding. And always link this with an item in the handbook, the proper item in the handbook, WHO handbook. So let's say that we have completed our investigation and we have seen that some of these food items are exposed for 7 hours. We need also to decide about high-risk foods and low-risk foods. Is unprotected, of course. And we need also to identify how food safety is ensured through temperature control or with time control. If it is a temperature control, we need to have proper equipment to measure the temperature of the food. If it is a time control, we need to review logs to see how long this was out of temperature. So here the corrective action is food intended for service, observed placed openly on a table in the crew mess without adequate protection. And in addition, we can link other codes like the code that is for time control or temperature control or protection from insects, etc. We continue with our inspection, and now we have visited a freezer. And we see this situation in a freezer. Do you have any concern? Can you see any public health risk here? Overstocked, untidy, overstocked, not labeled, poor or inappropriate storage. 3.3.1, no label, raw food on top. Sometimes some items reach roof, overstock allergens, use by date, fresh fish in freezer, no label, poorly arranged, contamination risks, overstocking. Many concerns for cross-contamination. No FIFO system. Very good, very, very, very good. So from this picture, we have made many observations. Maybe they are directly an inspection finding, but some others we need to investigate more. So we need to interview crew members. We need to see logs. We need to see procedures. Here we need to choose just one. Here we choose 3.4.2. Overstocked freezer units make this impossible to have proper air circulation. And then we have the corrective action. So this is not the only item that we can link with this finding. As I said, depending on the information we have collected during the inspection, we can link other items like the possible cross-contamination, the lack of labeling. Can we clean easily this freezer? No, of course not. Can we apply first in, first out here? Can we check? Can we check for expired food items easily? No, very well. Can we have packaging damage? Here, if we have food items stored one on the top of the other, not in shelves, probably on the deck. So overstuffing also increases this risk. I can see another very nice point. It's about training and about audit on board. So we can see, and this applies on any inspection item, we need to identify if this is a lack of a food safety system or procedures or training on board, or if everything is in place, but it's just that food safety staff is not applying. So all these things we can investigate during our inspection. We continue now, and we are inspecting an ice machine. And you see this situation here. The ice scoop is stored on the top of the ice. And what is the risk here? Can you see? Scoop left in ice, handle in ice. Very well. So we have the hand contact part of the scoop that is in contact with the ice. Can microbes survive in zero temperature, in the low temperatures? Yes, they can. So we may have contaminated ice that it will be consumed later, and we may have outbreaks and foodborne diseases, disease from consumption of ice, waterborne diseases. And we should not forget that ice ready to eat. So transmission can happen immediately. So ice scoop handle is in contact with the ice, and specifically the handle. So here we can see the corrective action. The ice scoop should be stored on a hook or in a container to ensure it is not buried by the ice. We want to minimize the hand contact with the product. Very well. And now we can see another observation. What we can see here.
Barbara, sorry
yes?
to interrupt. If we may just wrap up in 2 minutes, the exercise, that'd be great.
Yes, of course. This is the last finding. And here we can see in the galley a small gap, as you see, or something that is broken. Pest harborage, I can see here very well. Cracked wall, broken, difficult to clean, not easy to clean. Very well. So here we link with code 2.7.6. We have a large gap in the bulkhead. What is the risk here? Dirt can accumulate in such gaps. And of course, this can also provide space for harborage of pests, of cockroaches or other insects. So we need to ensure that seams are maintained in good repair to allow for adequate cleaning and disinfection and do not allow for harborage areas for pests. Thank you very much for your participation, active participation. Of course, we could continue for a long time discussing inspection findings, etc. What is very important is that you document all your observations and you link with the WHO handbook. Thank you very much.
Thank you so much, Barbara, for this very fun and engaging exercise. And I think all the participants really enjoyed it too, as we see many, many messages and responses in the chat. Thank you for that. And next, for our very last presentation of the day or of the entire webinar series, I'd like to invite Dr. Yaya to the floor for ballast water.
Before starting my presentation on ballast water, I would like to thank to Barbara because her pictures and her presentation is very useful for my, food safety presentation. Thank you for that good pictures. Let's start with ballast water management. As you know, we mentioned that the inspection of the ships is not an easy task because there are a lot of areas and many areas has large details like food safety or water safety. And some issues are, there are some issues are, we are public health officers, or public health staff are not very familiar with those issues. This ballast water management, such a area, we should inspect the ballast water areas or ballast water management on board ships. But for that inspection, we need to have some knowledge about the ballast water management systems on board ships. And the ballast water is a issue that, you know, WHO and support to in the latest time to support the all One Health approach, you know, including the environmental health, animal health, and human health. Ballast water, it's related to such kind of issues and show us the why we need to have a One Health approach in those risks. Let's start. In this presentation, we will talk about ballast water systems on board ships and how we inspect those systems. Yes, what is the ballast water? Ships use the ballast water to maintain their stability and navigate safely. And we can find some sediments. There are some sediments in the ballast water. We call them the sediments. And this is a system, ballast water management system. This system is used to prevent discharge of the harmful aquatic organisms mostly, and the pathogens. For that reason, these pathogens, for that reason, we mostly interested in the ballast water inspection on board ships. The harmful aquatic organisms is about the environmental health, but the pathogens is in our subject in public health. Ships mostly have ballast water when they don't have a cargo, and in the port when they start the loading operations, they pump their ballast water into the ports. So they transfer ballast water from one port to the other ports, or from one country to other country, or from one continent to the other continents. And according to the IMO, more than 6,000 marine species travel daily within the ballast water from one port to another port, because millions tons of the ballast water transported among the ships. Ballast water operations is a necessary operation for the ships, but carries some risks for the public health and for the environmental health. You can see some of the main risks, especially the risk of the bioinvasion. Invasive species, aquatic species may survive and multiply in the host environment. There is a lot of case in, as an example, for example, zebra mussels transport to the American, North America Great Lake and affect their freshwater systems. Another risk is the environmental risks. Those invasive species affect the local ecosystems of the ports or the countries, and the ballast water also can transfer the pathogens like Vibrio cholera. I put some a link of the one academic articles. There is a documented case that cargo ships with the ballast water transfer the Vibrio cholera bacteria because they attach themselves to the planktonic animals or zooplanktons or aquatic plants. For that reason, IMO, with the initiative of the IMO, a convention, international convention for the control and management of the ship's ballast water and the sediments, adopted and entered into force to prevent the spread of the harmful aquatic organisms and pathogens in ships' ballast water. This convention entered into force in 2017. There was a transition period, but now in today's world, the transition period is completed, and the ships must obey these convention. I put some of the IMO guides. There are a lot of IMO guides about how to prepare ballast water management plans or how to make the ballast water exchange. You can see those guides. And for the let's see a bit, examine the convention. According to the convention, ballast water management convention, ships in international voyage should have or shall have three important documents. One is the ballast water management plan. Another one is the ballast water record book and the ballast water management certificates. We can see some details of those management plans and documents. Management plan is includes a detailed description of their system and measures. You can see the ballast water logbook or record book. It's another important document for us. When we examine those record books or the ballast water logbook, we can understand how the ship make the exchange of the ballast water in the open sea or the situation of the ballast water systems in those record books, and the ships should make records when they treated the ballast water, when they take or discharge the ballast water. And the ballast water management certificate, this certificate issued by the administration flag states or by the recognized organization and the class societies on behalf of the administration. This certificate specifies which standard the ship or which systems the ship has on board their ships. The Ballast Water Management Convention has important regulations, A, B, C, D, E regulations, but 4 of them is very important for the public health officers, port health officers, especially D1 and the D2 is very important because D1 is about the exchange standard of the ballast water, and then D2 about the standard of the performance standard of the ballast water treatment. Let's see the D1 standard. According to this standard, ships make their ballast water exchange in the open sea. They should change their ballast water at least 95%, according to the D1 regulation. D2 regulation specifies the organisms and the bacteria of the discharge of the ballast water. According to this two regulation, you can see at least less than one colony forming unit for the toxigenic Vibrio cholera should be found in the discharge ballast water. And for example, Escherichia coli is a indicator of a very important indicator for the people induced contamination. You can see the standard levels should be there in the discharge of the ballast water. And D3 is about the approval requirements of the ballast water management. These systems include mostly a filtration period and the treatment systems. And the D3 is about the prototype ballast water treatment technology, and ships can have some transition period or time to experience according to these D4 regulations. And sampling is another important issue for the ballast water. There are some sampling parameters such as the salinity, temperature, organic matter, sediments. But the salinity test is a useful sampling method to understand that the ship is whether exchange their ballast water in the open sea or not, because the salinity of the open sea ocean is different from the salinity of the water near to the shore. And the samples should be taken near to the discharge line. In most of the countries, these samples taken from the port state controls. But if there is a problem or if there is a capacity, public health, port health officers can take those samples if they have a capacity. And the inspection. For the inspection of the ballast water, we don't have any chance to see their ship's ballast water tanks or observe, but we can check their documents, especially the ballast water record book, ballast water management certificate, and their ballast water management plan. And if there is some problems, we can make some extra inspections, or we can move forward to understand the problem and the control measures. We also check the sample results, or we can take samples for the ship sanitation inspection on board ships. That's all. Thank you for your attention. Over to you.
Thank you very much, Yaya, for the very informative presentation and for closing out our presentation segment of the webinar for the webinar series. So now I would like to launch our last poll question related to Yaya's presentation. And Yaya, I will invite you back to provide us with the correct answer. So the question has been launched, and you should see it on your screen. We have about 100 responses so far. I'll close it in 10 seconds. 223 responses, and let me end this here. So over to you, Yana.
Yes, E and C is the correct answer to understand the water exchange is fulfilled in a correctly. There is no questions in the ship declaration of health, so E and C is the correct answers.
Thank you very much, Yana. And with this, I hand it over to Sarah for the discussion session.
Thank you very much, Sophia, and thank you, colleagues. Again, sincere apologies because we didn't have the time that we allocated for discussion earlier. We have about 8-10 minutes for discussion now, and please rest assured that we are working to see different modalities to allow for more Q&A, for more discussions on specific technical topics in the future. We have seen many suggestions from all of you on specific topics that you would like to focus more on. So we'll be working on that, see what's the best way of facilitating informed discussions between 400, 500 people that we've had connected in these sessions. So for this one, if I can ask facilitators, if possible, to switch on their cameras. We have selected randomly a few questions for you. So I see on the screen, Yaya, there were a couple or 3 questions in the chat regarding food safety. Some of our participants were asking, what is exactly the role of the ship inspector? Should the ship inspector be involved in inspecting every single food item on board of the ship, or what should be the focus instead? Over to you, Yaya.
In the real inspection, we don't have enough time to inspect all of the food items, but actually it depends on the ships. In the small ships, we can have enough time, but in a cruise ships, we don't have enough time to see all the details. So what can we do? We can examine we can confirm or verify their documents, and then we can check the main areas, for example, storage areas and the galley areas, service areas. And if we have some problems, we can move forward to examine the details or ask some detailed questions.
Thank you very much, Yaya. I have another question here, maybe for Barbara. This is actually a question that we received in the chat regarding the use of silver as a disinfectant for potable water. I wonder whether you can share your response here with the group. Thank you.
Yes, Sarah, thank you. Actually, what is very important to say that any installation on board the ship, any new treatment, must before that must an assessment of the safety installation, and any consequences must be done by the proper organization or authority. So this must be approved by a flag state or a representative of the flag state. This is the first thing. The second thing is that we need, of course, to see the residual. So a specific kit must be available on board because they need to measure the silver ions, the concentration, the limits, the acceptable limits. Of course, maintenance of the systems, and possibly this can be used most of the times in parallel with chlorination. But we need to have the manuals of the manufacturer on board and an alternative system, because if this is out of operation, the water needs to be disinfected at all times and maintain a free residual.
Thank you very much, Barbara, for your answer. Next question will be for Rajdi. We received a question in the chat regarding the experience from countries with fumigation. In particular, who is responsible for doing it? What's the relationship between, let's say, a private actor in the role of fumigation versus a port health officer and the state party? Over to you, Rajdi.
Yes, thank you very much for the questions. So about fumigation, so each point of entry have its plan for vectors. So in this plans we have the surveillance, active and passive, and you have evaluation, assessment risk, and the step before the end is the control. For the control, we have we basically we using the insecticide. So in our country, the operation make by private sectors, but under supervision, border health control for the respect the plan and respect the technical and respect the insecticide level.
Very clear. Thank you very much, Rajdi. And then we also have a question. This time I'm going to direct it to Martin. Martin, we received a question in the chat, which we actually received quite often. And let's say it's in a scenario. Someone asked, what about smaller boats, private boats, that go in inland water, but undertake international voyage? Do they also require ship sanitation certificates? Over to you, Martin.
Okay, thank you, Sarah. Yes, this is a common question that arises. My understanding has been that under IHR, it doesn't matter what size the vessel is, what the nature of its operation is, whether it's a commercial vessel or a private pleasure craft or whatever. Under IHR, if it undertakes an international voyage, so it goes between points of entry between one state's party and another, then a ship sanitation certificate is required. That said, it is the state's party's freedom, for want of a better phrase, to be able to decide whether they wish to insist upon a ship sanitation certificate, either for a vessel arriving or a vessel that's going to depart for another state's party. A lot of that can be taken down to resources and perhaps the risk assessment of what sort of risk that particular vessel might pose. So states parties could mandate only certain types of vessels, calling at ports in their regions, to require a ship sanitation, and others they wouldn't worry about. So they could do that by legislation, they could do it by guidance to port health authorities or whatever. But under IHR, the summary is, if you undertake an international voyage, whatever the size of the vessel and whatever its purpose, an SSC is required, but it's the state's party's freedom and right to be able to remove the need to insist upon that. So I hope that answers it.
That's very clear. Thank you very much, Martin. Colleagues, unfortunately, we're going to have to leave the discussion session here. Again, thank you so much for all the questions that you have submitted. We will look forward to future opportunities to continue these conversations. And with this, I'm going to hand it over to Ninglan for the closing remarks.
Thank you very much, colleagues. So now we are coming to the end of this webinar. I really wanted to thank you for the depth of your engagement. Thinking about yesterday we were almost about 700 participants, and today we're also almost 500 participants. 3 hours per day, consecutive 2 days. That's a huge demonstration of your commitment to this area of work and advancing the implementation of the IHR in the maritime sector. So one of the reasons that we organize this webinar is that we have seen the variance in the inspection rigor, documentation practice, and the use of the Annex 3 across the different ports and different countries. So we see quite often there, the inconsistency in terms of this shipping inspection practice in the different ports. For instance, I make very frequent examples that the control certificate, when we see that, rarely we see any documentation of the findings. So when I say this is not criticism. I see this as an opportunity because that's where we can work together, highlight what we can enhance, what capacity we need to strengthen, and where we need to harmonize globally, and how do we update it in the future handbook or the guidance, WHO guidance for this area of work. So we really see this as an opportunity for this webinar. I wanted to first also highlight, we're not alone in this work. As a WHO, we have a very small team, but we are very, very lucky to have a very diverse network for global experts, including the collaborating centers. So today, for these 2 days, you have seen the participation of one of our collaborating center, which is the University of Thessaly, and we have the experts from UK, Turkey, Morocco, as well as our country participants from the Netherlands and Tanzania to showcase their national practice. And these are the countries from these 3 regions which our webinar is covering. We also have other collaborating center, another collaborating center in China, and we have experts from Canada, from Spain, who have been really supporting us for many previous shipping inspection training. So we will continue to work with this network on this important work. Also, since you are here, I would like to also share of one of our plea, because many of you may know that WHO has been going through quite a restructuring process. We're facing quite a significant financial constraint. And so we're basically exploring different means to continue to expand this type of training, continue to improve the capacities. So we also very warmly welcome any future collaboration with your countries, with your region, to advance this area of work. Now, I think I really wanted to also extend my sincere appreciation to my team, Sarah and Sophia, and of course, Supriya, who's the EPI-WIN moderator. They have been doing all the heavy lifting. This is almost a 3-4 months preparation with our regional focal points. Definitely, I wanted to also thank you, my regional focal point from Afro, Emerald, Euro. Without their organization, without the preparation, I don't think this webinar can be possible. So as we close, I really encourage each of you to take what you have learned and what you have shared and what you have exchanged back to your ports, back to your countries and your institution, and to reflect on the challenges and the variations we observed, and also think about how we can make the inspection more consistent and aligned with global guidance and standards. We will also continue to do our part together with our network of experts to organize more webinars, sharing guidance, and providing opportunities for Q&As. I see yesterday we got 84 questions, and today I think almost, I can't remember the number, but it's very close. So you can see the enthusiasm and the demands for this area of work. So now I think it's a time we close this webinar, but we will expect more to come. So thank you all once again for your commitment, your expertise, and your energy over these 2 days. We're really looking forward to continuing this work together and to seeing many of you in future trainings and collaborations. Thank you very much again.
Thank you. Bye-bye.
Thank you.
Bye, everyone.
Thank you. Bye.